we also have a tool or framework called Unity Mars. Unity Mars offers a feature-rich toolset to help make AR experiences more enjoyable to develop. So Mars is an authoring environment to help you more quickly create AR experiences that are flexible, customizable, and works across locations and data types. And this builds on top of AR Foundation's framework, as you can see. Let's take a look at what Mars is about.
What's Unity Mars? Well, certainly not the planet, but it really knows this world. Unity Mars gives you everything you need to create powerful, mixed and augmented reality experiences that interact intelligently with the real world at any location and with any type of data. Need to visualize a place or product, create a unique experience for an event, train up your staff? No problem. Imagine the possibilities as you author for games, sales, marketing, and more for any device or hardware platform. With Unity Mars, you can quickly capture and assemble real-world assets like locations, objects, and props. Then, just drag and drop them and test on the fly, all without leaving the Unity editor. Unity Mars experiences are powerful, interactive, and intelligent. Build once and deploy on any AR-enabled device. Get Unity Mars now and shape the world.
Okay, so Mars allows you to author AR apps more visually. Allows you to also test your AR experiences directly from your Unity editor without having to leave your screen. Because of the nature of AR, you actually need like a camera to use it. So normally you deploy it to your devices, like your iPhone or your Android device, because you need to leverage the SDKs of ARKit and ARCore. And with Unity Mars allows you to actually simulate that virtual space inside your editor instead of having to deploy it out all the time just to test. So it also works with unknown elements like fuzzy authoring and proxies to place stricter and more flexible conditions for how your AR content exists in the world. So to understand more about how Mars is critical to the experience, let's look at some AR development challenges. Now, first of which is authoring complex data-oriented apps visually. Realistically, it's impossible to know exactly where someone will use your AR app and what physical objects will be in their environment. So even if you're building for a specific or controlled environment, for example, a museum, floor plans and installation locations can change. And people viewing the AR experiences may do so from different viewing angles, and they could be of varying heights. And possible variables and their combination could be nearly infinite. It's nearly impossible to define manually when creating your app. So added to the tedious task of coding the dimensions by hand, you could spend a lifetime coding and still not have accounted for every possible variable. So next is being able to test your experiences in a painful and efficient way. It's highly likely that your physical space when you're developing your app won't be the same as the users when you're running it. You're probably developing in your office space, but you need maybe a living room or kitchen environment to test it. You can't teleport yourself to Tokyo if you're building a location-based environment experience for the airport yet. Right? For geolocation games, it's simply not feasible to test your app in every outdoor environment around the world where your app will be used. And this common pain point across development cycles. This is a common pain point across development cycles when you're building a mobile experience. So it's time consuming to also wait for build and test it on each device you want to work on. Then lastly, testing experiences. Good. Sorry, missed my last point there. And you need runtime logic that adapts responsively to the real world. right? So as mentioned, with the varying parameters that can change in the real world, you need an authoring tool that helps you define rules to place your dynamic objects. Right, so in the built-in simulation views for Mars, what you see is what you get. Here, visualize your content as your audience will experience it in context. Instead of coding, drag your contents directly into the viewer, and Unity Mars creates the appropriate proxies and conditions. So you're able to build your app with proxies that represents the real-world objects with frameworks in place. With a framework in place, you set conditions and actions for your proxies to tell your app how to respond to them. So these are some of the synthetic environments that you can leverage to kind of simulate the world you want to build on top of it. With visual aids for fuzzy authoring, you define the minimum and maximum measurements for the real-world objects rather than coding precise values. To help you get started, we've provided starter templates, which covers popular AR use cases, including training tutorial applications that work with all our indoor and outdoor environment templates. So this is sort of a guided training tutorial that lets our users see what Mars is capable of doing. And Mars is, of course, built on top of the Unity editor and works in coordination with AR Foundation. It exists as an additional layer that takes advantage of the data from AR Foundation or other custom data providers to allow creators to build for multiple platforms in a more streamlined and intuitive way. Fundamentally, Unity Mars provides the tools to efficiently author, test, and deliver AR apps. And AR Foundation is what makes it possible to have our augmented reality app work across various platforms. AR Foundation and Mars works together to make it easy for you to create and deploy more interactive apps and intelligently interact with the real world environment. So there is also a Mars companion app. That is one of the newest components to Unity Mars, and it's available for iOS and Android devices. With the app, you can capture real-world data directly on your device, bring it into Unity Editor, and quickly create and iterate your AR experiences to significantly decrease the iteration time and deliver an AR experience that accurately runs in its target environment. And Unity Mars gives you this power to perform two primary tasks: data capture and in situ authoring. Right, using the companion app, you can capture the room scans, take pictures, and record video with AR data. Once saved to the cloud, this data syncs directly to the Unity editor, where you can open it with Unity Mars to create a simulated environment that mirrors where your AR experience is intended to run. And now you have more true to reality development environment to author your AR content. Let's see here. So another example to add to the list of AR utilization is having play-based learning in AR. So in this Dr. Seuss educational app, using Mars allows you to easily classify parts of the environment to help our CG content interact with the world with defined rules, such as only spawning grass on the floor and not on the table, and allowing characters to jump on and off table surfaces, as you see here. Right. So Unity Mars allows you to simulate your experiences within the editor, meaning you don't have to build your app to your phone just to test. This cuts down time significantly in testing and allows you as a developer to just focus on building your experience just right. Okay, 1 second. All right. Lastly, we have Unity as a library. What is Unity as a library? If you have an existing app that's not built in Unity, you can still leverage Unity as a library within your application. And Unity offers controls that let you manage and the when and how to load, activate, unload the runtime library within the native application. Beyond that, the mobile app build process is mostly the same. Unity allows you to create and export iOS, Xcode, and Android projects, which you can just integrate into your native mobile app after. So here's an example of how you can load a Unity Unity instance from your native Android app and leverage the power of AR functions. As you can see here, we'll switch to the native app. And when you click the product, you'll just load up Unity. And you have the UX onboarding UI guiding you through it. And there you can see your product now realized in real-time 3D using AR foundations. And you can, of course, switch back to native and go back to Unity. Because Unity has already been loaded before, it's a lot faster the next time around. Cool. And you can use this feature to include Unity-powered features such as real-time 3D and 2D rendering, AR experiences, 3D model interaction, or maybe have some 2D mini games in your application. The Unity runtime library exposes controls to manage when and how to load, activate, download these content in your applications.